We're talking about substitution is a requirement, and when is U substitution a requirement and not just something that we do because we like to do it? When is it a requirement? There's really two criteria at this level. When the inside function is linear, that's kind of the second thing that would cross your mind maybe, or maybe you might notice it first. But when you check to see what the derivative of the inside function is, which could be linear, you're off by what? More than a constant. You're off by an x or an x squared or a square root of x. You're off by more than a constant. You're off by some variable. So when you're off by that and your inside function is either linear or smaller than linear, it can be degree less than 1, then U substitution is a very viable method, okay? So let's look at example 24b. Hopefully when you walk up, you see you have a quotient of two variable functions, and you would gravitate towards 2x minus 1 to be your inside function. You check to see what its derivative is, and you're like, 2. And you're like, I got a 2. That's not the right 2, though. So the 2 would be here, which is not a problem, but you know what? You don't generate the x squared. You're off by an x squared. You don't actually generate the x squared. So then you're like, okay, what other resources do I have? Well, is it an inverse trig? Could it be an arcsecant? It does have a radical with a function minus a number, maybe. But if that's u squared, then u would be the square root of 2x. And is the derivative of that x squared? Oh boy, I don't think that's going to work. Can I just square the top and square the bottom? Does that work? To get rid of the radical? No, that doesn't work. Ratcon! Radical over radical, you're kind of heading in the wrong direction. So at some point, by recognizing patterns, you actually recognize that it requires u sub. You're off by an x squared, your inside function's linear. So here we go, u equals 2x minus 1. So when you do u sub, you're changing everything from x's to u's. So I like to kind of replace them as I go. So the denominator now is the square root of u. Now if you recall from Friday, from example 24a, what's going to happen when u sub is required is you're going to have to replace your dx and your x separately. You're not going to be able to replace them in one fell swoop. So let's go ahead and take the derivative of u with respect to x in differential form, and we get du equals 2 times dx. Therefore, dx is going to equal 1/2 du. And you could replace the dx or the x in either order. It doesn't really matter. Sometimes it's easier to replace the x first and then the dx, or the other way around. But in this case, dx is 1/2 du. Now, the 1/2 is a constant multiple I can pull out front. And, of course, the du I put as the right bookend. Now, here's why we want it to be linear. I want to be able to solve that for x, so I can plug it in right there. And because it's linear, I can do so easily. I get u plus 1 equals 2x, which when I multiply both sides by 1/2, I get x equals 1/2 of the quantity u plus 1. And that's a little bit better than u plus 1 over 2, and certainly don't distribute the 1/2. So you can replace that with x. Now here's where you have to be careful. In this case, we have x squared. So what are we plugging into that parentheses? The quantity 1/2 u plus 1. Yes, as long as you move a 1/4. It's very easy to forget to square that 1/2. It is a 1/2 squared, which becomes a 1/4, which then can come out front with the 1/2 that's already there to become a 1/8. Okay, and then you're left with u plus 1 quantity squared all over, I'm going to call it u to the 1/2. So how does that put you in better territory than before? I mean, come on. The derivative of u is now 1. We're not, where you don't get anything. So, if you recall what I told you on Friday, the next step for every u substitution, once you replace the variables, is to what? Expand it out. Very good. It's always going to require you to expand it out. So you could have done that as you went from this step to this step. So square multiply double square. In the numerator, you get u squared plus 2u plus 1. And it's all going to be over u to the 1/2. But what's going to be required then, like in the early stages of our integration, you're going to have to split up every term and put them over the denominator. Or some people prefer to bring the u to the 1/2 to the top and then distribute it through to each term and add exponents. Either way, it's fine, as long as you get the same values. Now notice we haven't integrated yet. We're still in the process of cooking dinner and setting the table. It's not time to eat yet. So we got now to combine our exponents. We got 2 minus a half, which is 3 halves. Good. Plus 2u to the 1 minus a half is a half. And then here we just bring that to the top and it becomes negative 1 half. All right. Smells good. Let's eat. We're ready to, finally. The 1/8 goes along for the ride. Beefy bracket. I'm going to go with the beefy brown gravy bracket right there. Now, u to the 3 halves becomes u to the 5 halves. Now, look what I'm going to do. The very next step would be to replace u with what u is. So here's a time saver, if you want. When you're actually integrating, in place of u, just put parentheses. It's like a u that's not connected at the bottom. And really, why? See? u to the 5 halves, that was a silly giggle. Plus 2, leave a space. U, which is parentheses, 1 half plus 1 is 3 halves with a 2/3 out front. Plus, leave a little space. U, or parentheses, negative 1 half plus 1 is a half. Divided by half, same as multiplied by 2. You can put the plus c inside or outside the brackets. It doesn't matter. You put it inside the brackets and distribute the 1/8, it absorbs it. So I just put it out at the back. Now that saves a line of writing because now you can come in and in the parentheses you can put what? What u is, and u is 2x minus 1. So if it's an indefinite integral and you use u sub, that's the last step. You always have to come back and plug in what u is. And u, depending on the problem, is always something different, which is what I like about you. All right, let's do one last thing here, just to practice. We have little pieces of 2x minus 1 factors littered all over the brackets. Let's go ahead and factor out the smallest of the 3, the least powers, which would be what? 1 half. Now, I'm not going to mess around with the coefficients on the inside this time. So we're left with the 2/5, and then how many 2x minus 1s are we left with when I factor a 1 half out of a 5 halves? 4 halves or 2? Yeah. Remember, you subtract the exponent you started with minus the one you factor out because you're dividing. So you subtract exponents. Plus, we'll combine those to get 4/3, and we're left with 2x minus 1 to the 3 halves minus a half is 2 halves, or 1, so we don't need anything there. And then, of course, plus 2, because we take the whole thing out in the last term, plus c. So what that does is, inside those brackets on the end there, you could expand it out and kind of get relatively nice polynomials, and it would be partially factored in this case. Plus c. So a multiple choice answer could have it written in that format, just requiring you to go that one last little effort. So u sub, when your inside function is linear and you're off by more than a constant, replace all the variables, expand it out, integrate, and plug back in. Now these two right here are pretty typical of what you might see come Cinco de Mayo. But there are other varieties out there. This one here, let's look at it. It looks like it might be actually pretty easy. The integral of 2x over x plus 1 squared. What would you call the inside function? X plus 1. That would be essentially u, or the blob. What's its derivative? The derivative of x plus 1 is 1. Is that what we have at the top? Well, yes, but we also have a 2x, right? That doesn't quite work. Yay! So we're off by more than a constant. So, can we yeah, I'm going to pull the 2 out, right? Silly 2, you're not going to be affecting me at all. But whether we pull the 2 out or not, we generate a derivative of 1, not the x. We're off by an x, and x plus 1 is linear. So this is another good candidate for u sub. So we're going to let u equal x plus 1. And so immediately I'm going to go for u squared in the denominator. Kind of replace as you go. So now we just have to replace the x and the dx. And it doesn't matter the order in which you replace it. Let's go ahead and replace the x first, just to be different. Kicks and giggles and grins. X is equal to u minus 1. So I have u minus 1 in the numerator. Now here's the cool part. If you solve for x first, you could take the derivative of both sides of that, and you'll have it immediately solve for dx, rather than having to take the derivative first and then solving for dx. Solve for x, then take the derivative. You get dx equals, in this case, du. It's a straight exchange. But that's kind of a nice little thing to consider. Okay, so what do we do next? We replaced all the variables. That, by the way, could be a free a multiple choice question in and of itself. They could give you this and say, with the replacement, u equals x plus 1, what's your new integral? And that would be the answer choice. Yeah, we got to expand it. What does that mean, though? Expand it. I don't see anything to expand. Separate them. Yeah, u over u squared minus 1 over u squared. Or if you bring the u squared to the top and make it u to the negative second, then you can distribute it through. So you wouldn't have to show this middle line if you can go straight to 1 over u minus u to the negative second. However you want to write it to recognize it, if you want to call the first term u to the negative first, or you leave it as 1 over u, either way, it's the same rule of integration. And whichever way you're more comfortable recognizing it, just do what's good for you. What is the antiderivative of 1 over u, or u to the negative first? ln of the absolute value of u, and I'm just going to leave it as an open absolute values, minus u, which I'm going to put as parentheses, to the negative second plus 1 becomes negative first. And then if I divide through by negative 1, it's the same as multiplying by negative 1, which will make the minus sign there a plus sign. It'll change the sign. And then I can close the brackets plus c. So in place of u, I just left receptacles, open spaces, which I could then save a line of writing, come back in and put u back in there. And what is u? U is x plus 1. And you're done. If you want to distribute the 2, feel free. You could say it's 2 over x plus 1. That might clean up that second term. Just there's no reason to distribute. If you do, make sure you bring it to both terms. And then, of course, 2 times c, if you had the c on the inside, would be new and improved c. So it can be outside the bracket. Okay, so that one wasn't too bad. That one, I think, also would be within the realm of what you'll see come Cinco de Mayo on the AP exam. Now, these two here, I'm only going to do one of these two. Both of these fall kind of, I think, right outside of what I've seen in the past, but both still pretty viable methods. Which one do you think is more challenging? D? Well, let's come back and do D if there's time. I want to do E first for sure. If there's time, we'll come back and do D. Let's see if we can squeeze this one in before lunch. Letter E, or should we do D first? E. Okay, good. What would you do first? You would notice, what's the inside function? Oh, 2x. Okay, 2x is inside the radical. So what's the derivative of 2x? 2. We're only off by a 2. So we have a correction of 1/2, and what's the rule of integration? Yeah, that 1's kind of messing things up. I mean, if it were just the square root of the outer function, I would bring it to the top and use the power rule. Is it just the natural log of the absolute value of that because it's in the denominator? Well, I don't know. If you check and you take the derivative, you see you're not going to get that. That doesn't work. That stupid 1, he's messing things up. If he weren't there, it'd be easy. I can just bring it to the top and say the whole thing's to the negative 1/2 power. Be off by 2, power rule, done. But that 1 messes things up. What if we let u equal 2x? You think it's going to help? No? Ooh, the full 1 plus. Have you already tried with u equaling 2x? You haven't? But you know it doesn't work? Oh, you're just guessing it doesn't work. Well, let's try it. Let's see. If u equals 2x, if u equals 2x, then we get the integral of 1 over 1 plus the square root of u, and I just need to replace dx. So du would equal 2 dx, and dx would equal 1/2 du. Okay, so I can pull the 1/2 out front and put the du at the back, and now I reevaluate. What would you call the inside function now? Nothing changed. Nothing changed. You're right. We're in a different boat, but it's of the same make and model. We're in the same boat. We're still going down, right? This is like lifeboat 1, and that's lifeboat 2. And as Voltaire reminds us, life is a shipwreck, but we must not forget to sing in the lifeboats. So you were right. This did not work. Now, you said to take the entire 1 plus the square root of 2x is u. That's an interesting proposition. Let's try it. du is going to equal, 1 goes to 0. And then I get 1/2 2x to the negative 1/2 times 2 times dx in differential form. And now I got to solve that for dx, and I'm going to have another x there. Oh, these divide out. That's yay. So this becomes the square root of 2x du equals dx. But when I replace dx with that, notice I'm replacing it with something that has x in it. Ay, caramba. Took too big of a bite there. So, yeah, remember that the square root of 2x is really the same as the square root of 2 times x to the 1/2. And I said that u substitution works when x is linear or smaller. X to the 1/2 is degree 1/2. It's less than 1. So that would be something that might work. Let's try it. Let u equal the square root of 2x. So I'm going to have the integral of 1 over 1 plus u. And now I just have to replace dx. Now here is where I would not take the derivative of u right away, because I have an ugly radical over there. It's going to require the chain rule with the 1/2. So if I square both sides, I get u squared equals 2x. And now I could take the derivative of both sides implicitly with differential form. I get 2u du equals 2 dx. And I can get the 2's to divide out, and I get dx equals u times du. So I can replace dx with u, which I can put in the top, and then du there. Now, how does that help me? The derivative of the bottom is 1, which is not the top. I'm off by a variable. So do I let u equal 1 plus u and try it again? Oh, that won't work. You know what we use instead of u? We try v. There is something as uv substitution. Oh my gosh. Is it a natural log? No, it's not a natural log, because we're off by a variable again. It's unnatural. Well, I think lunch bell's going to catch us. We're going to have to digest this one over lunch and kind of share the contents after. That's gross. Share the contents of our lunch after lunch. We'll finish up this one after lunch. Have a great lunch, by the way.